Hey everyone, Michael Unger here with another edition of Ask an Astronomer. I'm here upstairs in our offices located on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh. And normally, Ask an Astronomer, we have our trusted astronomer, Marley, who is away sick today. Not to worry, she doesn't have COVID. She'll be back here in a couple of weeks. So this edition of Ask an Astronomer is just going to be me. AMA, Ask Michael Anything. So glad that all of you could join us here. If you have any questions about anything you've seen recently in space, you can put them in the chat, or if you can just want to hang out with me, glad to have you here. I have a really fun presentation cooked up for you folks. So hopefully you can play along, ask me some questions as we go along. We'll just do a show together. We'll have some fun as we go along. So we have, what do I've got for you today? I've got some wild space events. If you guys have been looking up what's been happening out there in the sky, or if you've been reading the news, you may have been seeing some really fun stuff that's been happening up there. So let's go over some of the top space stories that have happened in the last couple of weeks. So you may have seen some interesting lights up there in the sky, some greens, some reds, and of course, rare northern lights have dazzled Vancouver, Calgary, even New York. We have had some interesting light shows called the Aurora Borealis, the northern lights. The greens, of course, some reds that are particles coming from the sun. So what are causing these northern lights? So of course, all of the particles that are coming off the sun are coming off of this solar wind that is coming towards us in what we call an auroral oval. So most auroras occur in a band known as the auroral zone, about 3 to 6 degrees wide in latitude and between 10 to 20 degrees from the geomagnetic poles on all longitudes. So the sun emits lots of energy in small packets, and the magnetic field around the Earth protects us from all those particles and radiation. And guess what? The sun has weather. So during a coronal mass ejection, or a CME, electrified plasma leaves the sun and can move through space very quickly, and when it hits us, some of the energy and the particles travel down the magnetic field lines that concentrate at the north and the south pole. So in the north, we call that the Aurora Borealis, and in the south, we call it the Aurora Australis. And the particles interact with gases and molecules in our atmosphere, giving us those beautiful displays. So if you were out there and you looked up and saw some northern lights, some of the auroras around you, put it in the chat. I'd love to hear if anyone saw it. You know, I got the notice just perhaps maybe an hour before I went to bed that there was maybe a potential of some northern lights, but you know what, sleep went out and I went straight to bed. It's something I've never actually seen before. The one caveat that I will say is that when you do look up and you see these beautiful pictures, like if I go back and I show you some of those auroral pictures that were taken for around the lower mainland, those beautiful swirling dance of greens and reds, the camera picks up more than what you actually see with your eyes. But even with your eyes, it's still a beautiful display. So put in the chat if anyone saw it recently. So if we look at how we study close up, you know, we know ahead of time that these CME events are happening. And we have, of course, these wonderful observatories that are studying the sun that can give us an early indication of when they're coming. So on the left here, we have a picture of the sun from the SDO, the Solar Dynamic Observatory, and we're looking at the sun. The sun, of course, doesn't look turquoise. It'd be pretty cool if it did, but we're looking at the sun through X-ray and ultraviolet light. And the reason that we use that is that we can see what's actually going on in the surface. And as you can see on the left there, it's sort of like the top middle. We've got looks like something cooking up there. We have we have some fun coronal mass ejections coming off. And on the right, we have a different telescope called stereo. What stereo does is it blocks out the light with a large black circle, so all of the bright light from the sun doesn't blind out. We're just looking around the edge. And as you can see, there is a large explosion coming off the sun. We call it an explosion, but that CME event from stereo. And I kind of think of stereo as actually an acronym for Solar Terrestrial Relations Observatory Ahead. And I kind of think it looks like a record. I don't know if anyone else thinks that, with the black circle in the middle. If anyone remembers what records were, they're pretty cool. So all summer, we were looking at the sun through our telescope, of course, not in X-ray or ultraviolet light, just blocking out the bright photons and just looking at it in visible light. But as our nights get longer, of course, we have more opportunity to perhaps see some of these auroral activities, some of the northern lights. So I'll definitely be on the lookout for more alerts. You can sign up to some of these auroral alerts on your apps. There's lots of different apps that give you some warnings that perhaps there may be some activity that night, or you can just move up to the Yukon and Northwest Territories and Nunavut. I've got some friends and family up there. That's kind of the benefits that you get for living up there in the north, the beautiful northern lights. So let me know in the chat if you have any fun stuff that you have seen up there in the sky. But if you've been reading any of the news, there was another really crazy fun story, even here locally, that made worldwide space news. And that was a woman that was rocked awake by a meteorite chunk crashing into her bedroom. Did you hear about this? This is a crazy story. Ruth Hamilton from Golden, British Columbia. So Golden, British Columbia is sort of near the border of Alberta. And check out these photos, just incredible. A large chunk of meteorite crashed through her roof and landed on her bed. And on the left, the picture there, you can see a picture of the roof, and you can see that large chunk of rock that came from space. So quick review of some of our terminology. So a meteor, streaking across the sky, that bright flash of light, that's what we call a meteor. And then it becomes a meteorite when it lands on the ground. And of course, she had no idea what this rock was when she first landed on her bed. But now scientists are looking to study it. And lots of scientists saw this news story and were just wowed beyond belief, because this is an incredibly rare event, except that it happened last year, if you can believe it. Joshua Hudagalung, who is a coffin maker, if you can believe it, in a village in Sumatra, Indonesia. Also found, you can see the size of his meteorite, a little bit bigger than the one out in Golden. So that cut right through the metal roofing, and it buried itself at about 15 centimeters deep into the soil. And, so these meteorites are really interesting for astronomers to study. And if we go back to the story back in Golden, astronomers have gone out there and they've been asking people in the area to search the grounds before the snowfall. We're getting close to snow season. So they've been asking everyone that's been living out in Golden if they have found any small fragments. And they actually have. They found a ½ kilo about northeast of the town. And what they're doing is that they're actually trying to figure out the trajectory that this meteor came in, because they want to know exactly where in the solar system that it came from. And if they can reconstruct the path, then they can figure out where it came from. And these rocks, they were formed at the beginning of our solar system. So you can think about just how important some of these pieces are for geologists trying to figure out and study our Earth, because these are some of the oldest rocks in the solar system. These rocks formed at the same time as our Earth did. So if you just go out and try to pick up a rock outside of your house, those rocks formed relatively recent in the history of the Earth. But these rocks that came out from space, they are so old and really invaluable for researchers. And Chris Hurd, who was a geologist with the University of Alberta, he said this in an article about the Golden, BC meteorite, because it's scientifically even more valuable if we can reconstruct what the orbit was before it hit the Earth, because it gives us an idea where it came from. It's like sending a mission, a multi-billion-dollar mission to an asteroid and bringing the sample back, except here, didn't cost anything. It just came to us and landed on a bed. A really incredible story. You know, it's the stuff that I've always dreamed about. Things always happening, meteorites, you know, just falling on the ground around us. We actually have a piece of meteorite that's almost about the size, the same size as the one found in Golden and the one found in Indonesia in our cosmic courtyard. So if you ever come for a visit, and you should, we're open today, you can actually take a look up close at some of these large pieces of meteorite. So if we get back to where in the solar system these came from, let's just take a big picture look at our solar system again, okay? So here is the orbits of the inner planets. We got Mercury, Venus, Earth, and Mars. And the main asteroid belt is where we're thinking a lot of these meteorites are coming from. This is the area that we really want to concentrate our efforts and look out to, because if there's anything large, and of course this piece that, you know, landed on that bed out in Golden, relatively pretty small. I mean, it may have caused, you know, obviously some roof damage. If it actually did hit her, you know, when she was sleeping, that may have caused some issues as well. But there are a lot bigger objects out there that we want to go out and try to find, because those are the ones that can cause some real damage. And the main asteroid belt is where they're coming from. So that's largely where we're concentrating our efforts and looking out to try to find these objects. But as you can see in this picture, there is this other area, these other asteroids that you may not have heard of, called Trojan asteroids. And this is where we get to our next story today, talking about those Trojan asteroids. And they live, as you can see, they live in this area that we call Lagrange points. Lagrange, that's Lagrange, Lagrange. It's kind of a fun word to say. So Lagrange points are these pockets in space, these gravitational points that are at balance between two objects. So those Trojan asteroids are at balance between Jupiter and the sun. So if we take a little look here at the Lagrange points of the Earth-Sun system, we have 5 points, and most two objects have 5 Lagrange points. So we call them L1, L2, L3, and L4. L4 and L5, you may have noticed, those were where those Trojan asteroids lived. L4 and L5 tend to be stable, and they actually pull objects into them, into these in-between zones, if you will. Now, the L1 and L2 systems, as you see here in this picture, L2, we're going to be talking about a lot more in the next few months, because that is where James Webb is going. Those L1 and L2 points end up being really good places to send satellites to, because you don't need to do readjusting on them. So lots of satellites that are in orbit around the Earth, you end up needing to readjust for their orbital periods, or else they come too close to the Earth, or vice versa. So when you put the satellite out in the L2 region, it can just stay out there, and you don't really need to do much with it. So with James Webb, that's where it's going to live, beyond the moon's orbit, as you can see there. So if we go back to the Trojan asteroids, what's really cool is that these asteroids, they just kind of linger in those Lagrange points. They're either, you know, in front of Jupiter in that L4 spot, or in the other trailing Lagrange point in L5. And these Trojan asteroids, you may think about why they're called Trojans. Well, if we go back to do some storytelling here, you know, the Trojans and the Greeks were at war with each other, and actually the names of each of the asteroids in each of those areas are named after some of the characters in that Trojan Greek war. So you have the L4 Trojans, and then you have the L5 Trojans, which are actually more the Greek characters. So we're going to get in some of those names, because there is a mission. The reason I'm telling you all this is because there is a mission going to visit these Trojan asteroids. That is the Lucy mission. So Lucy is going to be taking off of Earth in these really eccentric orbits, as you can see here, going around the Earth's sun, doing some gravitational assists so that it can get out to the L4 region. And the L4 region is going to have lots of different kinds of objects that it's going to be flying past, and then it's going to be going and visiting some of these worlds that have names like Patroclus and Menoetius and Eurybates. I'm not even sure if I'm pronouncing these right, these crazy Trojan and Greek names. But as you can see, you know, they're lumpy, they're big rocks, but they're very interesting rocks that could really be those keys to unlocking more of the mysteries of our solar system, because we have never been in this region of space before. It is getting close to launch window. So October 16th, we are getting to the beginning of a 23-day launch window. So Lucy spacecraft, as you can see here in a few of the photographs, it's going to be on top of an Atlas V rocket. And in a few days, that launch window will open up. And the Southwest Research Institute-led mission is going to begin. And it's going to take about 12 years and about 4 billion miles for this record-breaking 8 asteroids that it's actually going to visit. Really cool mission that's going to be coming up. So we're going to be talking a lot more, of course, you know, over the next 12 years, probably, hoping that Lucy eventually gets to those Trojan asteroids. Yeah, so I've got tons of stories back here. Lucy in the Sky with Diamonds. You know what, Pride? I was just listening to an interview with some of the scientists that were putting this together. And lo and behold, Ringo Starr actually made a little video, and he did the drum fill from Lucy in the Sky with Diamonds and sent it to the scientists, wishing them luck on the mission. So Ringo Starr, definitely a space fan, but really cool connection there. So yeah, for the rest of the show, like I said, it's just us. So any questions you had about any of the top space stories we had, of the auroras, the northern lights, and the meteorites that have fallen and almost landed on people, and of course the Lucy mission, really fun stuff. I've got a question from well, actually, Keith mentions that the meteorite at the Space Center is unexpectedly heavy. Yeah, it's mostly made of iron, and if you've ever picked up iron, super heavy. But you can definitely try that next time you're in our gallery space. For Marino asks, is there any way to factor out the components, chemicals of the meteorite that they actually do to its contact with the Earth? Yeah, absolutely. That's what they have actually done. So as soon as this story hit, a lot of that geoscientist that I had mentioned, Chris Hurd from the University of Calgary, he went back and they grabbed the rock and they have taken it back to do some study on it. Now, you may wonder, you know, did scientists actually steal, you know, this meteorite, which is worth some money? Like, let's not kid around here. You know, this is a bit of a lottery win for that woman that had the meteorite crash through her roof. Of course, the insurance is going to pay for the roof. And that meteorite, if she wants to sell it, she can put it out there in the market, just like Josh did out in Indonesia. He sold his meteorite. I looked up some numbers. I wanted to try to find out exactly how much he sold it for. There was some speculation that perhaps it was like in the millions of dollars, but it wasn't in the millions of dollars. There was a BBC story that came out last year that found out that it did sell. They didn't say exactly for how much, but that Joshua, he was happy with the price that they found. Because if you look up on eBay, you know, sometimes the prices are wildly different. And that really just depends on demand, on what someone is willing to pay for. Now, the problem with these larger rocks is that they're actually not from a collector standpoint, not as interesting. So apparently the larger the meteorite, that actually the less valuable it is. So hopefully that doesn't give, anyone any ideas about splitting up the rock to make more money. But you know, those larger ones, they're really heavy, and you know, they're hard to cart around. But yes, so the scientists have taken it and they're going to give it back. Not to worry. They have said that they have until November to study the rock, looking at the components and the chemicals from that rock. And then they will give it back to her so that she can maybe sell it, and maybe buy a new house. Awesome, folks. Well, we've got about 10 minutes left in our Ask an Astronomer. If you have any other questions you have about anything that you've seen up there, we've got some new shows that we have debuted here in the planetarium. If you've come for a visit, we have some new ones. We've got one that's narrated by Neil deGrasse Tyson called Seeing. That's a photon's journey across the galaxy. That's a brand new one that we have in the planetarium. And we actually have a event, if you can believe it, an in-person / online event that we're doing with the Dark Matter Institute out at UBC. So Dark Matter Day is a day that is celebrated, quote unquote. Well, it's a day that lots of different science-minded people use because it's kind of a spooky day, Dark Matter. Halloween, October 31st, is the official Dark Matter Day, but on October 30th, inside of our planetarium theater and online, we are bringing 4 of the top dark matter researchers from UBC together for something we call Dark Matter Day. And we're going to be in the planetarium looking at some interesting visuals, looking at the 4 different perspectives that these scientists have taken. And they're taking different approaches. And they're also have been working with some artists. There is an art gallery out at UBC called the Belkin Art Gallery that has this dark matter art display right now called Drift, and they've actually worked with some artists thinking about how to visualize dark matter. And so this is going to be a really cool event. Check our website, spacecenter.ca, to get tickets. You can either come in person, it'd be wonderful to see any of you inside of our theater physically, or you can also stream it as well. It's going to be, we're going to have live simultaneously. This is something we have never actually done before. Makes me kind of nervous, but we're going to figure it out. It's going to be a lot of fun. Yeah, so thank you guys so much for joining me on the AMA, the Ask Michael Anything edition of Ask an Astronomer. If anyone else has any questions out there, we can hang out. We've got about 8 more minutes. How's everyone's week so far going? Well, I don't see any more questions coming through. So why don't we wrap this show up just a little bit early. We will be back in 2 weeks with Marley. Don't worry, Marley will be back in her trusted position here, hopefully with some Lego. She had promised us last show that she was going to show us her Lego collection. So from me, Michael here at the H.R. MacMillan Space Centre, thank you so much for joining us for another edition of Ask an Astronomer. We will see you in 2 weeks. Bye for now.